Hello, Algebra 1 students. This is our third and probably not final because I always say that and then I'm wrong SOL review video. I'm going to go back and break my rules again and start playing music with lyrics again, but the air conditioning is going to come on any minute now. So beware for the loud noise, at which point you probably won't be able to hear the music anymore. But let's get started. Okay. So here we have a multiple correct answer question. You know how I've been talking about these gray bars? Here it is up here. Now, on this, you probably notice it, but when we try the practice interface in the classroom, you're probably going to notice that it's kind of, it just disappears to the eye. So it's something to think about, okay? All right, so this is a systems of equations, or solving an equation question. Let's read it. Michelle correctly solved the linear equation, and the last line of her work was 1 = 2. Which statement best describes the solution to the equation Michelle was solving? This to me indicates that there's one statement. You see this? On the statement you want to select. Click on the statement. So I think there's only one answer to this one. So let's read them all. The only solution is 1. The only solution is 2. The solutions are both 1 and 2. The equation has infinitely many solutions. The equation has no solution. Well, in order to figure this out, we're going to have to analyze what we're looking at with that individual solution, which is 1 = 2. Which is patently false. We know that that's not true. If that's not true, then that's going to be a no solution equation. If we saw infinitely many, we would see an answer like 1 = 1 or 2 = 2. If the solutions are both 1 and 2, we'd be talking about in what we've learned this year, we'd be talking about a quadratic equation. And it definitely doesn't indicate that. If the only solution is 2, we'd see x = 2. And if the only solution was 1, we'd see x = 1. Okay, so clearly, the only possibility is that there's no solution to it. All right, next. Okay, a set of data. Oh, again, invisible gray bar. Click on all numbers you want to select. Only select the correct numbers. So this is multiple correct answer. Okay, so it's going to be more than one. A set of data for the number of points a basketball team earned for each of 9 games in a tournament is shown. The mean for the data set is approximately 80.1. The standard deviation is approximately 6.1. Using these approximations, which scores are within 1 standard deviation of the mean? This is not that hard. The first thing I should probably do is recognize what I'm talking about here. So I'm going to use the symbols for mean and for standard deviation. Within 1. Let's think about what that means again. That means 1 above, 1 below. So let's find out what those two boundary numbers are. We're going to add 6.1. and get 86.2, and we're going to subtract 6.1 and get 74. That's the range of values that we're looking at. Conveniently, they have put these in numerical order for us, which is something you should definitely check before you start doing the problem. All right, so within that range, we're looking for numbers that are between 74 and 86.2. So, what are those? 75, 78, 80, 82, and 85. And those are all the ones we would select. That wasn't hard at all, as long as we know what we're talking about when it says within 1. Next. Okay, so you have a table. Let's look at the table a little bit. So relation, which statement's true about the relation? Before I look at the statements, let's look at the table. 1 and 10 are ordered pairs, 4 and 2.5. 8 and 1.25, 20 and 0.5. So clearly, as this side, as the x's are increasing, the y's are decreasing. Now the first thing that says to me is inverse variation. So that is definitely a possibility here. So let's look at this. Yes, I was right. Inverse and direct variation. Is it a direct variation because we have this? Is it an inverse variation because we have this equation? Now, a couple of things that I would do. Say that you were struggling during the test and you did not remember anything about these, you're having trouble. You're like, oh my God, I'm blanking. I'm just totally blanking. I don't know what any of this means. You're going to write down as much as you can think of for each concept. Direct variation, as one increases, the other increases. So that's the first indication that the ones that say direct variation are going to be wrong. Inverse variation, definitely as one increases, the other decreases. Let's go to the next step. If you remember more, you'll remember this. For direct variation, y = k times x, and y = k over x for an inverse variation. All right, so at this point, it's clear that we're not dealing with b either, because look at that equation. this definitely does not fit this set of data. It may fit one of the ordered pairs, but you cannot rely on that being right for all of them, so it's important that you check multiple ordered pairs. And the only one it appears to fit, I think, is the first one. Okay, anyway, continuing. We only have one answer choice left, but let's make sure that this is right. So let's take the ordered pairs and plug them in. So 1 times 10.0 is just 10. Does that equal 10? Yes, it does. So x times y. Yep. Same thing for the next one. Yep. Same thing for the last one. Yes, indeed. D is our correct answer. Next question. Okay, in which table do the values represent the rule shown? The square of the sum of x and y is equal to 5. The square of the sum of x and y is equal to 5. So let's write that equation. Let's write that equation. So the square of the sum of x and y. The sum of x and y is this. The square of that is on the outside. So we're squaring that sum, and that's equal to y. So the square of the sum of x and 5 is equal to y. So let's try plugging in the values. So we have 3 plus 5. Whoop, sorry about that. I didn't mean to move it. 3 plus 5 is 8. Squared is 64. So that first one is not working. Okay, I'm just checking A here. Plugged in 3, did not work. B. 3 plus 5, the quantity squared, still 64, not 14. The only one that fits is C. Now, what would have happened in the beginning if we didn't understand what we were reading here? Well, it's important that you try to break it down. The square of something, we know something is squared. So when you see that, try writing your parentheses and putting squared next to it, because you don't know what's squared yet. Do not assume it's just x. Okay, look at what at how it reads. The sum of x and y. So the sum of x, and 5, not y. And it's equal to y. So it's important that we can break these things down. If that's a skill you need practice with, talk to me. We can find it on Khan Academy for you. Next question. All right, so here we have a cube root, and we're plugging in the values. This is a great question for your graphing calculator. Let's just go ahead and start plugging in. So I'm going to write the entire expression. Whoops. Except without the values of the variables. In fact, let me go ahead and put like some parentheses and stuff in here. There we go. Let's drop our numbers in. We got A of 8, that goes here. We've got a B of 16, that goes here, and a C of negative 4. So 5 times the cube root of 8. The cube root of 8 is 2. Minus negative 4 times the square root of 16, which is 4. So I did a little bit of the math, and then I'll continue on. 5 times 2, 10. Minus negative 16 is the negative 4 times 4, plus 9. 10 plus 16 plus 9. 26 plus 9 is 35. So our answer should be B. So it's plugging in the values. So really, what are they testing us here? They're testing us to make sure you know what a cube root is, and to make sure you can deal with this minus and then plugging in a negative. So it's important that we use those parentheses to begin with and make sure we plug the numbers in correctly. Sweet, we're moving along nicely. Let's keep going. Okay, which inequality is true because of the division property of inequality? So we start off with this inequality here at the top. And this is kind of a jerk inequality here, because this one, we can't avoid needing to flip the symbol. We just can't really avoid it. So what they've done, if I look at my answer choices, is every single one of them has the divided by negative 2 to start off with. Oh, I didn't mean to make that quite so long. All right, so the first thing I notice is that if you look here, on this side they divided by negative 2 for C and D, but they didn't do the right-hand side. Well, that clearly is wrong, because that violates one of our properties of inequality. You know, the properties of inequality say that you can multiply or divide both sides by the same number. The key is to make sure you recognize what's different about these two. All right, what they're trying to make us remember here is that as soon as you write that divided by negative 2 on both sides, this symbol no longer works. And I'm scribbling it out because it won't let me erase. I have to flip the symbol around, making my correct answer B. Makes my correct answer B. Because as soon as I divide by that negative, that symbol has to get flipped around. And that's really the only thing this question is testing, is do you remember that specific key point when you are solving an inequality. All right, next question. Another factor completely. So we're going to be doing an activity in class before the test that involves dealing with this factoring completely stuff. And I want you to remember a couple of things, okay? And I know probably by the time you've watched this, sorry, my skirt is stuck in my chair. Only I would have that problem. You know what I mean? Okay, anyway, I want you to remember a couple of things. You, of course, should just be able to factor this. So you should just take out the GCF, and there definitely appears to be a GCF because both of those, all three of those terms are divisible by 3. So, that's the first thing, and then go ahead and factor it. But if you struggle with factoring, you absolutely can use trial and error to figure this out. It's just going to take a long time. So I'm going to go ahead and factor it because I know that we can do that. And I'm going to take out the 3. So automatically, as soon as I see that, I'm going to go ahead and select that 3. Nothing's divisible by 9 besides the first term, so it can't be a 9. What do I get when I factor out the 3? I get 3x squared minus 13x minus 10. And so now I've got something I have to factor. I'm not going to be able to go straight to that, so as soon as I wrote that, I said, oh, no. What I need is my A, C, and B method. So A is 3, B is 13, and C is 10. So AC here is 3 times negative 10 or negative 30. I need factors of negative 30 that add to negative 13. Automatically, you guys are going to go for 10 and 3. But remember, that would be two numbers that would multiply, give you 30, but they won't give you negative 30. So what I have to do is go through and find the factors of 30 that have a difference of 13. It's clearly not 1 and 30. There it is. And the 15 has to be the negative to add to negative 13. See how organized that was? I just kept it organized, went straight forward, not hard. Next step to remember, keep your front end, keep your back end, split up your middle term. I like to put the negative first. I find that it's a little bit easier for some of us if we do. I've already selected my 3, so I know it's there. I don't want to drop it, but I don't have to worry about it right now. Now I need GCF here, GCF here. GCF in the first pair is 3x, leaving me x minus 5. Now remember, if you know that's a 3x, think instead not of not dividing it out, but of what has to go in the parentheses to multiply by 3x and give me 3x minus 15x. Must be x minus 5. Also, this has to be linear, meaning there's no x here now because I took it out. In the next step, I know this has to be x minus 5, and the only number I could multiply through x minus 5 and get 2x minus 10 is a positive 2. I have my 3 out front. I have my 3x plus 2 and an x minus 5. So 3x plus 2 and x minus 5. Awesome. 2 more questions and we'll be done. Okay, so I had that fun moment where the air conditioning or heating element comes on and scares the daylights out of me, and I may have said something that's not video safe, so I'm going to have to re-record this slide. Let's see what we can get done before kids start showing up. All right, the mean for a data set is 45. The z-score for a data point A is 0. The z-score for a data point B is 0.2. Which are the possible values for data points A and B? Well, what do we know? We know the mean is 45. We know the z-score for a data point A is 0. Now, a z-score of 0. Let's think about that z-score formula real quick. What's the only way we're going to get a z-score of 0? The only way to do that is if this value right here is equal to the mean. To have mu minus mu over sigma. That's the only way you're going to get a 0 here. So data value A must equal the mean. Okay, so look at your answer choices. It's not A, it's not B, because they say that data value A is 0. All right, a z-score of 0.2. Well, that tells me that my value is greater than the mean, because a positive z-score means the value is greater than the mean. So look at your last 2 answer choices. This one is greater than the mean, this one is less than the mean. Must be C. Must be C. All right, last question. The mean of a data set is 30. The mean of a data set is 30. The standard deviation for the data set is 3. The z-score for a data point is 2.25. Now, that's a very high z-score. Very high z-score. So, again, let's think about what we mean here. We know what we know here, not what we mean. There is the mean. Sorry. Sometimes I stumble with my words. There's a couple ways I can do this. I can try to use some process of elimination, and I'm going to go ahead and do that first. Now, look. A z-score of 2.25 means that the value we found the z-score of is substantially above the mean. So that means A and B are not going to work because both of those intervals, both of those numerical intervals are values that are less than 30. See that? So, not A, not B. The next thing we can do is we can take our z-score formula. And I'm just going to write z instead of z-score. It's x minus mu over sigma. Now think about this for a minute. We know 3 of these 4 values. We know the z-score. We know the mean. And we know the standard deviation. The only thing we don't know is x. We can find x. We can solve this equation. This is just a 2-step equation. It's not even a hard one. It does have this big fraction, which I got to remember to start off by getting rid of that. So let's multiply both sides by 3. 3 times 2.25. 3 times 2 is 6. 3 times 0.25 is 0.75. So 6.75 equals x minus 30. And then we're going to add 30 to each side. 36. Oh, I ran out of space. 36.75 equals x. Only possibility is right here because that number's got to be bigger than 36. So I can use that equation. I could also have worked backwards by finding a z-score for the number 36 to see if our value could be less than that. And if you find a z-score for 36, 36 minus 30 over 3, that's 6 over 3. That has a z-score of 2. So that wouldn't have worked either. And that's going to be it for this third SOL review video. Thanks for hanging in there till the end. See you in class.